next session, which is a panel discussion on India's march towards semiconductor capabilities for future. We have three esteemed personalities to be the participants here and two from virtual mode. First of all, it's my pleasure to welcome the moderator, Mr. Surinder Singh, to kindly come over. Ladies and gentlemen, give a round of applause. I would also like to call upon Mr. Barun Datta from IMEC to kindly come over. Mr. Aries Imberman from Tower Semiconductors. And we are going to have Mr. Rajkumar of IGSS Ventures and Mr. Rajesh Nair of Global Foundries will be joining us on the virtual mode. Just a quick intro about our moderator. Mr. Surinder Singh is leading SCL Vision to build a strong microelectronics base in the country and facilitate development of VLSI and MEMS devices and systems. Several awards and accolades have followed Mr. Surinder Singh. So let's give a round of applause for the moderator and the esteemed speakers. Sir, in the interest of time, I'm straight away handing over the session to you. It's over to you. Yeah. It's on, sir.
On?
Yeah.
Thank you. So, good afternoon to all of you. It's my pleasure to be among the best brains and some of the global stakeholders. And of course, I have the company of some of the world leaders in the semiconductor manufacturing. At SCL, some of you may be knowing, but the others, for the benefit of others, I like to tell that we have a very small scale compared to the global standards, a small scale CMOS foundry, and we are mainly working for Indian space program. Of course, we are supporting academia along with that for all their R&D endeavors. From the morning you are listening about the importance of semiconductors, so I need not re-emphasize the importance to this august audience. I also need not emphasize how big the market India is, but I like to bring to your kind notice that these are the consistent efforts of Government of India that, as you have seen in the morning, that electronic production, manufacturing, that has gone, it has almost doubled in the last 5 years to $75 billion in 2021 from roughly $37 billion in 2015-16. So semiconductors, realizing this, that they are the essential building blocks of this modern smart society. You see, everything is moving to smart, and the more we are going towards smartness, the more SEMI is needed. So this has been in the morning, in most of the talks you have seen this. So seeing this, so Government of India has taken very big initiatives to bolster the last critical link, which is semiconductor manufacturing. As I said, we are there, and compound semiconductor also in the country in a very small scale is present. But of course, we are missing the scales which are needed to meet what is the demand which is shown is coming in the next few years. So seeing this, there is a lot of efforts, and the Semicon is also a part of these efforts. So taking this forward, I think the Government of India has laid the semiconductor manufacturing policy, and a good response is received regarding that. And as I said, though we have been doing it on a very small scale, but when we are moving forward, now this is the opportunity that probably we have a look at now the way forward, how we have to go so that we can, as rightly said by Ajit sir, that how to shorten the path for the gap which we have with the world. So we have to take right steps. We are taking a small step, but we have to take the right steps so that this gap, we can shorten this gap and we can move forward for all our needs. So with me, the very eminent, as I said, personality panelists are there who have really a very, very big, good experience in semiconductor manufacturing. I'd like to introduce them because it's a virtual, as two of my panelists are joining in the virtual mode and two are sitting with you. So I'll first very quickly introduce them to you, and then probably we'll move for the panel discussion. I thought that because, as I said, that we have to take the right steps. So the central theme which is very, very consonant with this, our panel topic of India's self-reliance in semiconductors. So I thought that probably the panelists can speak on that how we can establish a very robust and sustainable semiconductor manufacturing in India. Of course, there are many aspects which are related to this, as most of the speaker you have listened, like whether this is they can add in their talk or in their views that regarding whatever the supply chain problems are there or talent pool. Augmentation of talent pool has been told by Vaishnav ji in the morning talk, that what are the steps being taken. But along with the augmentation, the one more difficulty is retaining such talent. So if they can, if anybody can take and talk on that. Of course, there are many other challenges. Seeing the current global scenario, you all know, so there is a big rush for setting up fabs world over. In fact, by 2024, nearly 100 fabs are going to be set up. And this is just a beginning. So how we have to move forward so that we are not denied the rightful place which we need right now. So along with that, I think the panelists can also elaborate that what are the roles probably of the academia or R&D center or fabs which can play here in having this goal. And over and above, as Honorable Minister said, that we need a very, very candid feedback. Though the policy is well laid, as said by Ajit sir, but still, if the panelists find that there are still certain things they need in the policies or regulatory mechanism or in long-term commitments from the state or long-term goals or any stone they feel is still unturned, they can really highlight that when they are giving their views on this topic. So I'll very quickly introduce all the panelists. On my right side, Barun Datta is sitting. He's Chief Scientist at IMEC. IMEC is a R&D hub for nanoelectronics and digital technologies, and it has established itself as world leader over the last 30 years in nanoelectronics. He has pioneered a novel and unique collaborative model that encompasses the entire semiconductor value chain that combines global talent and world-class infrastructure. Founded the Euro practice, most of the designer and users who are sitting here, they know this. So he's founded the Euro practice IMEC Link, a unique design ecosystem to enable academia and SMEs to assess advanced foundry technologies, designs, and packaging tests. Barun returned to IMEC as chief scientist in 2010 and leads and has led various R&D programs across IMEC semiconductor R&D ecosystem, from new materials, device technology to life science tech and neurotech programs. From 2000 to 2011, he was a venture capitalist and general partner at Rosen Alta Berkeley, and incubated, co-founded, and invested in 14 successful semiconductor and system technology companies. In his earlier careers, he was at Bell Labs and Texas Instruments and was first customer assignee at IMEC in 1994. So give a big hand. On my left is Mr. Erez. Erez is a good friend and partner. I must tell the audience here that they are our technology partners. The small foundry, whatever small foundry we have, has been set up along with the Tower Jazz. So Erez was appointed as Vice President of Business Development and Special Projects in 2010 to manage worldwide business, especially in India and China. So under that itself, we started getting the TOT from TSL. Previously, he served as Tower Semiconductor VP, Global Supply Chain Manager. From 2005 to 2010, he served with Intel Corporation as Engineering Department Manager and Fab Establishment Program Manager in Israel. Prior to 2005, he served as Tower's Fab 2 Manufacturing Director, Fab 1 Manufacturing Manager, R&D Director, Productionization Manager, and Test Manager. And prior to which, he was employed by the National Semiconductor in various engineering and management capacities. Please give a big hand. Mr. Rajkumar, who will be joining us in the virtual mode. He is the founder and group CEO of IGSS Ventures Private Limited. IGSSV is a technology investment holding company with key subsidiaries focused on delivering unique capabilities across three key segments: disruptive semiconductor technologies, IPs, and fabrication. Pure play foundry services in specific technologies, and truly unique plant and fab foundry transformation services. Mr. Raj held various senior leadership roles with increasing responsibility prior to setting up IGSSV. In his previous roles, he was responsible for $2.5 billion revenue from 6 world-class foundries with 7,000 employees. Also managed a global business unit of US $1.2 billion. He has also chaired boards of various international semiconductor fab joint ventures. In 2012, he was elected to Singapore National Productivity Council, representing the semiconductor and electronic industries. So our last panelist is Mr. Rajesh Nair. He is the Vice President for AMS and eNVM Technology Solutions at Global Foundries. Raj is located in Santa Clara, California. Global Foundry is a pure play foundry with a broad suite of technologies supporting mobility, automotive, industrial, and compute applications. Global Foundry has manufacturing facilities in Singapore, Dresden, Germany, and Malta, USA. Global Foundry has a growing footprint in India with over 700 employees at present. Raj has over 25 years of experience in semiconductor industry and is one of the pioneers in the field of smart power technologies. In Global Foundries, Raj is the R&D leader responsible for developing critical technologies that can be found today in many smartphones, electric vehicles, and IoT devices. He has previously led the mainstream CMOS business unit with over $2 billion revenues, and prior to joining Global Foundries, Raj held executive positions at Maxim, ON Semiconductors, and Motorola. So I welcome all the panelists, and seeing the time paucity, I straight away request Barun Dattaji to give his viewpoint on the topic which is there right now, establishing a robust and sustainable semiconductor manufacturing in India.
Hello?
Thank you.
Okay, I'll take a shot. I think what I think is, what at least our experience from IMEC has been that the semiconductor has multiple pillars, but what IMEC has focused on has been to establish, I would say, a global R&D platform. And this addresses both the medium-term and the long-term needs of the industry and the ecosystem. I think if you do one thing about what we've learned over the last 25 or 30 years in the semiconductor industry is that the semiconductor ecosystem is a very long-term play. And it's something that needs support across all stages of the ecosystem. You can't, it's very difficult to pick and choose winners or in particular sectors, unlike many other places, because it's a very dynamic industry. It is foundational. What is today's software is tomorrow's semiconductors. That's what it is. Okay, in the classic sense that what paper was to the Renaissance, semiconductors is to the digital age. It's that powerful and universal. So the emphasis on, and I think Ajit raised this, emphasis on talent training is one aspect, which is mainly the resource of the universities and academia. That needs to be strengthened. It needs to be focused. Semiconductor technology and its design side is the most demanding engineering skill that is around. And that is benchmarked by the, if you look at all the benchmarks of the National Academy, they all say that. So it's a question of training, and it's critical not only in quantity but in quality. This is one of the emphasis on quality and programs and modernization is critical. The next part of it is what I would call is the R&D platform which every country who's a dominant player has. I would say IMEC is one of the few places because of its location and its neutrality. We are a global player, but every other nation has an equivalent national platform. That's true for France, that's true for Germany, that's true for the United States. Might be it's not that well structured, but it does exist. That's true for Taiwan, that's true for Korea, and it's true for every other nation. Okay? And I think the emphasis here has to be that that needs to exist. So at the national level, there has to be, let's call it, whether you call it a national lab or whatever it is, or an extension of how SCL has played. That's a role which is very important. There is the academic role, and then there is the entire manufacturing and design ecosystem. I think the design ecosystem is very well developed here, but I think it also needs to transition from a design services to a product ecosystem. And this is an issue because all the creativity to support the local ecosystem is going to come from people who understand the local applications and demand. And that, I think, is where the next phase of the growth is going to come from. If you have these fabs and other fabs, I mean, I think this is just the beginning. You might get a few fabs now, but I think the process has to be that I think you should look at it that every year there should be a new one for the next 10 years or 15 years. Okay? So this is not an event, but this is a process. And the R&D ecosystem will grow to support it. Okay? That, I think, is the purposeful destination, without which I think it's going to be a challenge to sustain it. Okay? And then you can talk about competitiveness, which is going to be local driven, as well as I think one of the great opportunities today is how do you become the most sustainable, greenest semiconductor manufacturing in the world? I think Ajit alluded to that. I think we, for instance, have just had a very new program which started off in sustainability, which has had is having very fast growth and rapidity. And this is the unique opportunity. Today, nobody has a perfectly green or sustainable. They have missions, but this is a long-term process. But this is where the R&D plays a role. Okay? You could argue that since this is a new industry, that it is in 10 years' time, compared to anybody else, it's the most green manufacturing in the world. Okay? So you can think about, I think the sustainability has to be in short, medium, and long term. Talent buildup is the longest term short term to longest term requirement. And there is a medium-term requirement in pathfinding and pathfinding R&D, which will allow the creation of new applications and new technologies to support the entire infrastructure.
Thank you, Parn. So you said that there has to be a national platform similar to what the IMEC is. Of course, IMEC model is very famous model. Those who are in the business, they know this, and it is not easy to have this model everywhere. But what will be your suggestion? See, as has been emphasized by everybody right from morning, there's a good talent available in India. So what will be your suggestion to us? The few fabs will be coming. Do you suggest to have a R&D fab or center as written along with the production fab in first few fabs, or you will suggest that it should be totally separate from the manufacturing?
I think this is a difficult question, and it depends actually on it's all about timing when the manufacturing infrastructure gets built. But what I'm saying is these pieces, if you take a chessboard, you can't be missing the knight and the rook and try to build an ecosystem. Okay, and I think if you go back and look at 30 years ago, and if you ask the two founding directors of IMEC, Professor Vanova and Gilbert de Klerk, if they'd ever predicted what IMEC would look like today, I don't think they wouldn't have got it right. I was one of the first assignees. I can tell you, we didn't know that it was going to work out this way. Okay, so I think it's very important that they are in some way connected. I don't think they should get isolated. I think that's the most dangerous thing. They need to be connected. Potentially, they could be co-located, but I think they do not have to. I mean, I think, as you can see in an IMEX case, all our customers are all over the world, so we have figured out a model by which it can work. So I think, but what is important is that the steps are made. I don't think you can have the gaps in the ecosystem. That is the critical part. And I think with what you have to start, and you have to be flexible and evolve. And I think that's the important thing. Okay? You have to make the start, you have to move with what it is, and then add on to it. And you have to be open to that. Okay? And I think that's the critical part of it. It could be that you create a mini fab next, that might be the right solution for a 300 millimeter. It might not be the solution for might be an 200 millimeter platform. It can be extended. So I think it's a mix and match depending on what is the right thing at the right point in time. Okay? But I think the openness and commitment needs to be there both at the national infrastructure level, but also on the academic side. I think as much as you've got a big talent pool, as Ajit said, we need to strengthen it much, much more, because the success of the industry is going to depend on the future students being trained now. Okay, they are going to build this industry. All of us are in our 50s. But when I look at it, I mean, none of us have enough gray hair, black hair left on our head. So we are not going to make this industry successful. The next $500 billion is going to come from the next generation. Okay, and we have to make sure that we build a platform that they can run with it, and it's their creativity that's going to do this.
Thank you, Arun. Thank you for your kind words. And another thank you for keeping the time. Actually, I request all the panelists to be roughly within 10 minutes because we are already running late. So I invite now Erase to express his view on our central theme.
Namaskar.
He's more Indian than...
Despite...
I just want to say one thing. Whenever he comes to FAB, I understand now half of the Hindi, so we are afraid of talking in Hindi before.
That's what I want to say. Despite the fact that I'm visiting India in the last 12 years, I think 100 more times, the only word that I know is Namaskar. And this is responsibility of Director ACL, that he didn't teach me anything despite we working together for the last 7, 8 years, whatever. So sorry about that, but great honor to be here, really. I really appreciate the invitation. And before I give you a few of my views on these things, because I have so much to say about that. But I want to take one step before and talk about the two ministers and Honorable Prime Minister. They talk in the morning and take one theme from what they say. So the Minister Chandra Shankar asked at the end of his lecture, asking, is it possible to do in India? So my answer for that is yes, in one word. If you ask me in 2 words, I would say it's absolutely yes. The theme that I take from Minister Vishnu is he is saying, rightly, that this is not a sprint, this is a marathon, and I totally agree with that. However, I would like to say that the marathon did not start today in India. We are in the middle of the marathon. I don't know exactly if the 5th kilometer or the 10th kilometers, but for sure it started long ago, and right now we are accelerating toward making more progress on this marathon. And third, and not least, of course, Mr. Modi, which is initiated all this program and all this slogan that we see here, the Make in India, Digital India, Skills India, and all these things together, for sure, this is a great initiative, and I think this is an excellent program that very welcome in India, and I'm personally, as an outsider, really excited to be part of it. Now, also Prime Minister Modi talked about 6 points from his point of view. I have my 6 points separately. I assume they are quite having some in common, I assume. But I'll tell you in a second what are my points in this view of making semiconductor manufacturing in India. But before that, I want to tell you that first, as I said, I'm very honored to be invited to here on behalf of Tower Semiconductor. And also, if you look closely, you can see that I'm wearing a pin here that has Israel and India flags together. And this is celebrating this time the 30 years of collaboration between Israel and India on business and diplomacy. So I'm not a diplomat, but still, I like to mention that there's close cooperation between Israel and India, and I'm very happy to be part of it as well. So to the point, I think that setting a semiconductor in India is having few critical things that need to be taken in consideration, and most of them are taken care right now, and I think they are in a very, I would say part of them are very advanced stages, and part of them need more. But first thing, and we heard about it a lot also this morning and in the last months, is the government support. So government support to initiate and push top-down this initiative is super critical because it's, first of all, it's how it started everywhere in the world, right? Every country that started semiconductor started with government support because it has so much of a capital and so long of a return of investment to build the market, to start running ecosystem and having everything in place. So government must be active role on that. And we've seen right now that with the policy that announced in December and the program that they initiated in the ministry, in the government is really focusing this time on doing that. The other thing, the second point, from my view, is the Indian partner. So Tower is an Israeli company and international cannot do anything without strong Indian partner because there's a lot of things that, with all due respect, that I'm here so many times, I know almost nothing about India and need somebody that live in India, understand the culture, have the connection with the government, with the regulations, with all the different roles that they need in order to initiate this semiconductor manufacturing. There's many, so it must have a strong India partner, business partner, virtual capital partner, somebody that supporting this activity. The third one is the technology partner. Technology partner, As my friend from IMEC say, and we all know, it's critical, and it is recommended, not that India cannot develop it by itself, but you cannot invent the wheel right now, and it takes a lot of time and a lot of efforts, and when it's available on the shelf, and somebody, tower or like tower, again, I'm not selling tower right now, but tower like tower can license technology to India for their demand. That is the best to do in order to accelerate the time to market, as we say. The fourth point is the supply chain and or ecosystem. And two of those words, buzzwords, people are talking about them so much. And I think there is a long-term and short-term in this ecosystem and supply chain. And when we talk about fab establishment, there's something different that you need the land and the water and the power and the waste water and all the facility ready. And for that, again, you need strong support from government, from local government, state government, where you are going to put the fab, to understand the regulation and to get all this infrastructure. And when you get into production or ready to production, the supply chain or the ecosystem is different, because then you need all the material, gases, chemicals, specialty gases, test wafers, sputter targets, slurry for CMP, a lot, hundreds of different materials that are supplies, including the machine, the equipment, spare parts for the machine, services for the machine, and a lot of things that this fab need in order to be operational in a good mode. The next one is the point of know-how. So again, there is a lot of know-how how to run manufacturing fab. Okay, engineering system, manufacturing system, and you need this fab to be the, I would not say best in class, but at least the outstanding industry standard, so people will have incentive to manufacture in this fab. Otherwise, this fab, if it not be in the world standard, why should any customer do the design and manufacture in this fab? So all the know-how how to do that and how to make it outstanding and best in class in the industry standard, this is again, you need someone that have the knowledge and the capability to give the address. And last but not least, and people talk about it a lot, is the resources. So I don't agree that it's need to be started from zero. There are so many Indian talents in every semiconductor company in the world, manufacturing or not manufacturing. There are hundreds of talents. Most of them, or few of them, are sitting on the top level of the companies, and they are, I assume, they are really ready to come back home, come back to India, in case there is jobs and there is semiconductor manufacturing in the country, so they can serve instead of doing it outside, to come back and do that. And I know that from my experience in your facility, Director, that the people that we try to bring, we hire a lot of people from Singapore, from out of India, and they come back, and they're happy to come back, and they're very experienced. And hand to hand, all the program that people are talking here about connection to the academia and doing the training program, etc., this is, of course, is a very high priority.
You finished?
Yes, thanks.
Thank you. It is, because it is, as I told initially, he has been responsible for developing many fabs, not first in India, and then in China and Japan also he goes. So with the current geopolitics, you have emphasized on supply chain. So the global supply chain challenges, what you feel, what are they right now, and what it means for the timeline in which we are thinking of putting a 300 fab?
Wonderful question. You know, today the world is suffering for supply chain not related to India, but when we try to expand our fab in whatever, in the US or in Israel, the lead time for the equipment is very long, right? Everybody know now that if you're asking a scanner from ASML, they will give you a lead time of a year and a half or so. And you're talking to Applied Materials also. The lead time of equipment is between, I would say, best case, 8 months, 6 months to a year and a half. So this is a very, very long, that's one example of the equipment. That's the bad news. The good news is that we did not start construction yet, the fab in India. And this by itself is going to take about a year and a half to 2 years. So if we're going to initiate the fab in India and hand-to-hand be smart enough to start and issue POs for the critical lead time items like tools and other material, that will fit the schedule, it will not affect the schedule. And I think you're asking general question about the schedule, so from my experience, to build such a fab from after government approval and everything in place, from groundbreaking until you start making products after construction and tool and installation and technology, verification and qualification, it can take minimum 4 years. Okay, so that's a long journey, and the supply should be taken into consideration as well, as I explained.
Thank you, Eres. We are already, I think, running late. So I'll now request Mr. Rajkumar from IGSS Ventures to give his viewpoint on our central theme.
Thanks, Surinder. Can you hear me loud and clear? Can you hear me?
Yeah, we can hear you very clearly.
Okay, great. Okay, firstly, namaskar, okay, and a good evening to all. Okay, and since the main theme is how to have a robust and sustainable semiconductor manufacturing ecosystem in India, I would like to touch on some of the fundamentals, okay? So, I was fortunate enough to have close to 3 decades of semiconductor fab, especially semiconductor foundry pioneering background, okay? And India is late, okay? Let me be frank, India is late by 35 years or more, depending on which semiconductor segment you're looking at. But there's one key advantage if you're late. There's many disadvantages, but there's one key advantage if you're late. And that advantage is to learn from the mistakes and the positives of other semiconductor nations that started before India. And there are many valuable lessons that India can learn from there, which can be a very strategic value to India if we know how to use this wisely. Firstly, for example, the budget is $10 billion. I think it's a reasonable budget to start off with, okay? But it is not a budget that can compete with some of the nations, semiconductor nations in the world. Okay, China, for example, in the last 30 years could have easily invested $500 billion in semiconductor. US, the pioneer in semiconductor IC chip design, even today is spending 40, 50, 70 billion dollars. So India's 10 billion is a decent number, right? So then we need to know how to optimize this dollar much better than the previous semiconductor nations. If we can optimize $1 in India in semiconductor investment equivalent to at least $2 or even more, because this is what I meant, that we need to learn from the mistakes and the positives of other nations, right? Then the $10 billion which comes from the government, and assuming another $10 billion comes from the private sector, okay, that 20 billion can be equivalent to 40, if not 100. That is the differentiation, right? So when we talk about optimizing the dollar, okay, and how to optimize semiconductor journey in India, okay, to the max, then first thing we need to look at is which technology space we play. So I'm going to confine myself to manufacturing in this case, so semiconductor fabs. And that is going to be the group that's going to take the biggest capex and investments. So broadly speaking, there's two groups in semiconductor technologies. Okay, the digital technologies, or better known as bleeding edge technologies, which can cost $20 billion or more per fab. Okay, so just take note, $20 billion or more is 2 times the total budget that we have in India. And then we have another segment of technologies which is known as more than more technologies, which doesn't follow the Moore's law, right? That has a lesser total project cost to start a fab. And today, globally, okay, I think the data in 2021, the total semiconductor TAM is about $600 billion, $630, $650 billion. Close to 45% of that is still based on non-digital technologies. So India, with $10 billion and starting late, etc., one key strategy here can we focus initially on the more than more technologies, where we can get the biggest buck for it, right? And when I say that, okay, I'm referring to say, yeah, we can have 28 nanometer all the way to say 0.18 micron, where there's still very important products and requirements. What goes into your heart, for example, pacemaker is old technology. What goes into the EV cars, there's a lot of old technologies. What even goes into the mobile phone has analog mixed signal, power management, high voltage chips, and etc., etc. Nothing wrong with digital, but if it's my own money, okay, will I take that gamble in the beginning, putting up $20, $25 billion in the very first fab at this stage? Likely not, right? But we can look at 14 nanometer and even maybe 7 nanometer in phase 2, phase 3, and etc. We can, right? But we got to study it correctly. Another thing that is important is there's close to about 300 fabs today, globally, 200, 300 mm. There's still some 150 mm fabs. I'm referring myself to silicon fabs, consisting of IDM fabs and pure foundry fabs. It is very important at this stage when we start fabs, we need to have vital differentiation. If you do not have vital differentiations, why would they come to India? So why I use the word they? Huh? It is initially for the first 5 to 10 years of global business. India's ecosystem, we have heard many knowledgeable speakers saying that India has very large design capabilities, etc. Very true. But there's a difference between partial design capabilities and full fabulous capabilities. And full fabulous capabilities in India is still at the early stage. The positive part is the raw talent is tremendous, and if they are enabled in the next 5 to 15, 20 years, this can be very successful fabulous entities. But we cannot wait. We cannot wait for 10, 15 years to fill up this fab in India, right? So that is very important for the future of these fabs in India, but initially this fab got to be world-class, which in my term will be tier 1 foundry fabs, right? Which is truly world-class, which I believe one of my panelists was just referring to that using another coin. It has to be world-class, tier 1 foundry methodologies. So you need to have an entity that has that capabilities, that experience, and more importantly, willing to impart that knowledge to India. That is very important, right? The next point that many have said, and I'm going to also say that, okay, that semiconductor investment is, especially for greenfield fabs, is a very expensive investment. So throughout the world, and we spent 2 years in discussions with MIT and Niti Aayog and many others to convince that Indian government has to come in aggressively to support this industry, especially in the beginning. Okay, we looked at examples in Taiwan, in Singapore, in Malaysia, and China, obviously, even in US, right? After 60 years being the #1 semiconductor nation, they're still pumping in $50 to $70 billion in 2022 onwards, right? So government of India is going to be very important, and I think the policy, I agree the policy is a good start, a very good start, okay? And what is important is to launch the semiconductor project, the semiconductor fabs timely. Okay, I'm not sure how many in the audience knows that India's journey or interest in semiconductors started even way before 2008, right? So there's more than 14 years that's passed by, and semiconductor industry basically runs at a fast lane, right? It's very dynamic. we have lost many opportunities in the last 10 years, especially with M&As and et cetera, et cetera. So launching it timely is very important to gain the global industry's attention, because some of them are relatively wary. Okay, it is great that India has came up with a policy. It is great that we have Semicon today. It is very important that we get into execution, right? And yes, do it right and select correctly. In that light, okay, I would like to just take the last few minutes to say what I believe is very important when we say that we need to learn from the mistakes and positives of other nations, right? So decision makers need to understand the difference between a satellite fab that is brought to India or any other country, for example, versus a concept of HQ-centric fab that is more focused on creating a win-win with India and also the global industry. There's a big difference, right? So if you look at Taiwan, more than 38 years ago, a group of IDM semiconductor experts came to Taiwan and eventually started off TSMC, right? And they had a good partner in Philips, which later became an XP. If you look at China, you had American Taiwanese, I believe, okay, who went to China, okay, with people and together with the Chinese government, they funded them and et cetera, and that created SMIC, right? In both Taiwan and SMIC, the flag bearers of semiconductor technologies and foundries in Taiwan is TSMC, in China it is SMIC. Take China, for example. There's many other fabs in China which are satellite fabs. Intel has a satellite fab in China. I use the term satellite just to show the difference. TSMC have satellite fabs in China, which are still 200 mm or doing old 300 mm technologies. It is SMIC that is driving the roadmap in China. Same thing in Taiwan. You have many other IDMs having fabs in Taiwan, but it is TSMC that does the best and greatest things in Taiwan, right? So that is a key difference between a satellite fab concept and a HQ-centric concept, right? It really determines the success of the industry in the given nation. Don't take this wrongly. It doesn't mean you do not need globalized support, global collaboration, etc. I'm a firm believer in global collaborations, right? And we do that a lot in my previous life and even in IGSS ventures, even more in IGSS ventures. We have partnerships with IMEC, we have partnerships with local universities, research institutes, we have partnerships with global universities. So you need to have global collaboration because it's a global business. But India needs to also have localized entities or adopted entities who are willing to create win-win with the government of India and Indian entities. That's very important. If it's going to be solely dependent on foreign entities, many nations who use that formula did not succeed. Okay.
Thank you, Raj.
Yeah. In the interest of time, you would like me to stop here?
Yeah.
Okay.
It would have been much better had you been physically here, so we would have had the more opportunity to talk to you. Raj, I just want to, you have said that learning from mistakes, okay? So you have pointed, you are saying that budget optimization, technology mix, right technology mix, you are saying, technology optimization, okay? See, we, as I have areas also regarding supply chain and seeing the current problem, what will be your viewpoint for setting up quickly few 300 fabs? Would you suggest going for the totally new equipment, refurbished equipments, or acquiring certain, see that is also an optimization which probably has been suggested at many places, acquiring a fab anywhere available right now because of the geopolitical conditions. So what will be your opinion, see, in this kind of global scenario? So what optimization you suggest?
Okay, there are many, but in the interest of time, since you mentioned refurbished equipment, right? okay, we took 2 years to convince Indian government that they need to support refurbishing. Okay, even in Singapore, which was a pioneer in semiconductor foundry fabs, we started foundry fabs in Singapore in 1986. Taiwan started in 1985. So in those years, there's only two foundry nations, right? Today there are many, right? So we started using refurbished tools in Singapore, even when I was working for Temasek or later on for Global Foundries Mubadala, which are some of the richest national investment entities. I was using refurbished tools wherever I can, right? It doesn't mean you don't use brand new tools. You got to use a combination depending on the technologies you're working on. So refurbished tools is a must because it reduces capex costs, right? So keep this in mind, right? If we are starting a fab, say in the next 2 years, we can't wait for 4 years. In the next 2 years, the fab is operational, right? It is going to compete with fabs in Taiwan, China, Singapore, US, Europe on similar technology nodes, which was started 10, 15, 20 years ago, right? So how are we going to be cost competitive? So one way is refurbished tools. Second way is every dollar we spend, we optimize it because the other nations in their early years made a lot of mistakes. We can't repeat that mistakes, right? So yes, refurbished tool is a way to go, right? Having strategic partnerships with the key OEMs is a must. So for 28 nanometer, you can still get majority refurbished tools, but today refurbished market is also in hot demand, right? So it's going to be a combination of refurbished tools and brand new tools, right? But that's just one aspect of it, huh? Okay, you got to know how to have your technology strategies, how you combine, okay, certain emerging niche technologies with mainstream technologies so you can have better financials, less competition, right? If you're going to create a Me Too like 35 years later, you're just increasing the challenges of making this fab successful in India. But if you still can come 35 years later and be a leader in certain emerging technologies, that's the way to go. And India has a lot of talent. Okay, there's the second largest engineering resources in the world. It has the youngest youth population in the world, and it has a very attractive domestic market in the future, right? Which by putting in these semiconductor ecosystems and making the right decisions across fabs, foundry fabs, across design houses, there's also a world of difference between having world-class partial design services and having a complete design capability to come up with products, right? And India has the raw talent, but it's not there yet in terms of having 20, 50 proven fabulous domestic companies in India. And here I think we got to also play both the Indian card and the global card. It's okay to adopt, okay, world-class designers who are willing to come to India to start up the company. Why not?
Thank you, Raj. Thank you. I think
Thank you.
Erez wanted to have a
Just
quick reaction.
one comment about the tool refurbishment. So tool refurbishment is a good solution. The problem is that it's timely and a market condition. You know, today there is zero refurbishment tools available in the market, both for 300 millimeter and 200 millimeter. So I don't know when this fab will come and need the tools. Maybe the condition will be better, and then we can use refurbished tool. This is the condition, so we should keep it in mind.
Thank you, Erez. So now I welcome Mr. Rajesh Nair, and I really appreciate he is awake in this late hours, rather early morning, I say. So I really appreciate your commitment. Sir, I'd like to have now your views on our central theme. Please go ahead. Thank you.
Sure. Can you hear me okay?
Yes.
Okay. Yeah. Firstly, thank you, and it's a pleasure to participate in this panel. I know we're running a bit late, so the advantage is most of the salient points have been made, so I can maybe just emphasize or add a couple of points. So in terms of supply chain, right, we had with COVID a black swan event. We had people starting to work from home, so lots of bandwidth requirement. They were starting to shop from home, starting to get entertainment from home. So that built a lot of demand. And then along with 5G and also vehicle electrification, the demands have gone very, very high. Okay, so, and then people, I think, have realized that having semiconductor manufacturing just in one or two countries is not healthy. And also they have understood that having some resiliency in countries that you can depend on, some of it in your own countries, is critical. So I think that is going to play in India's favor. Okay, there's a $2.2 trillion electronics market, and below that is about $550 billion of semiconductors or semiconductor products, and then underpinned by $90 billion of foundry, okay, give or take. Okay, this is where Erez, myself, and then also Raj Kumar and Ajit used to be, and I believe still are to some extent. So this is the ecosystem when assembly lines in automotive plants, mobile plants started running dry. People understand now the value of having resilient semiconductor supply chains. Okay, so that is actually going to play in India's favor. Now, in terms of, we talked about supply chain of fabs, but in turn, fabs need an enormous supply chain and ecosystem. You cannot, you have some tool down, you cannot have spares coming in from Singapore or Taiwan all the time, right? You need to have all these vendors, equipment guys with their own spare systems locally, and also have trained equipment suppliers who can repair and maintain these tools. So that should be considered a very critical part of that ecosystem development. So that were the couple of points I would make on supply chain. On developing and retaining talent, I think most of the points were made. As was mentioned by Barun and Ajit especially, we have a massive talent problem. With the millennials, we want to make semiconductors cool again. A lot of us are gray-haired people, as Barun mentioned, and the next generation, we need to tap into that talent because they're going to take us to the next level, right? And with a trillion-dollar semiconductor industry, so make semiconductors cool again. And what do they care about is should be very important, right? Diversity and inclusion, equity, interesting and challenging problems to solve, green manufacturing. Those kind of things have to be highlighted by the industry. Okay, so that is important. And then in terms of talent, of course, this is also where partnerships with companies like Global Foundries and IITs, etc., to build that talent would be quite useful. And actually, GF is doing that. We have 700 people in India. They're not IT and finance people, okay? They develop our design kits, they do demo designs, they do models, they also do some fab activities. As you know, a lot of fab activities can be done remotely since these are all automated fabs. So this all can be done. And also labor arbitrage is not as critical, in semi-industry compared to maybe other industries. You pay for talent wherever it is. Okay, we have people from 90 countries in Global Foundries. So a good device or integration engineer, well paid is more than, 4 or 5 mediocre device or integration engineers. So paying for talent is almost like, IPL, you pay for the big hitters. So that should be critical. Now, in terms of policies and regulatory support, Global Foundries didn't say we're going to build a fab right away, right? But we are playing a long game. We are certainly growing our skills in India and growing the talent pool. In terms of what else can be done, I would say, think of this as a sustained partnership. You look at Raj Kumar's look in Singapore, the EDB model where they will assign someone to you for a few years, then they do rotate, just like Indian civil service. But they're assigned to you, maybe they're assigned to 1 or 2 other companies, and they really understand your business, where they can help, how they can make connections, etc. So it should be considered a very close partnership rather than a standoff relationship. That's one point I would make. Another place that you could help is, of course, building the customer base. Now, it's great that India is now a very big auto manufacturer and a handset manufacturer, but also building designs coming out of India and nurturing that is should not be minimized as part of the ecosystem development, and also nurturing corporate partnership, for companies like Global, and I think Erez mentioned Tower also. We like to partner to be more prominent in the Indian market. The third point on the topic of policies is, I think Barun touched on this. All these places with significant semiconductor presence, they have a local lab or fab, and often it came out of that, including Taiwan, of course, with the ITRI, but IME in Europe, Sematech in the US, etc. So that should be also considered. This is a very innovative industry. Large chunk of the engineers are actually doing R&D work and development work. So this is a very critical part of the ecosystem. Last point I would make is, in terms of lessons learned, and Rajkumar could add more, but try to build a hub where 5 or 6 fabs can be located, so that the equipment folks, the manpower, etc., is a lot more fungible, rather than having one fab each in 7 or 8 different cities all over the country. Okay, and this model hasn't worked in a few other countries. So be cognizant of that, and have enough power and land and water, etc., where many fabs can come into one location. It becomes a hub. Actually, very successfully in Bangalore, for example, in the IT space, but we need something similar in the semiconductor manufacturing space. So I'll pause here in the interest of time.
Thank you, Mr. Nair, for your valuable suggestions. I think the panelist has given their wonderful views. However, I'll again persist with one last question on the theme. See, I still will like to invite your suggestions on, like Ajit sir said, that the world took almost 5 to 6 decades to reach the level where they are right now. And we are starting. So we need not, and Mr. Raj has also touched on this, that we should learn from the mistakes, as well as you said, that we should learn from the experience of others. So how we can, again, I'll say, shorten this gap and move quickly in setting up a very robust and resilient, I'll say, semiconductor manufacturing system in India. Any last quick suggestions any panelist or all panelists can have?
I think you have the answer here. All the people that just talk here, so much experience and have so much to say and so much to contribute, and happy to help. So I think the best you can do is using the world support in order to accelerate and make it outstanding, best-in-class manufacturing as soon as possible. So just get, my friend in the panel, you have all the answers here. So just do it. In this industry, things are too dynamic. It's not just about nodes, it's about products being dynamic. Okay? They will change dramatically in the next 3 years or 5 years, I think. So it's important that these, like I said, there should be a fab being built every year for the next 10 to 15 years.
Thank you, Baran. So I think we'll conclude this session. I think the last point I want to say is that with the strong government intent, and of course, the government support, which probably I'll like to repeat the Honorable Prime Minister's words, which he has said, that I'll talk to you in terms of the microelectronic itself. So he said that the government is going to be an AND gate which is really very encouraging and very encouraging for all of us. So with that strong government support and intent, and of course, as has been pointed out by a panelist, a good collaboration from all of you experienced stakeholders, probably I think the small step we are taking will certainly very soon become a giant leap in the semiconductor manufacturing for India. Thank you. Thank you all for the patience.